While seeing this type of notation, most of us feel very uncomfortable because most of the people don't understand what it's mean actually. So let's suppose we have a Cartesian plane over here, where, for example, we have some function. For example, let's suppose here we have a random function. So obviously we would have some points. For example, it is point A, it is point B, anywhere it is point C. Okay, so let's suppose if I am saying x belongs to, this means belongs to, x belongs to. So when I'm saying x belong to interval between A and B, so it's mean it refers to the interval. For example, A and B. Okay, it's mean it is the interval. For example, these 2 points. So that's mean x is a point which is between, somewhere between A and B. Okay, so let's suppose we have a random graph over here. So let's suppose we have some graph over here, and let's suppose it is a function. For example, the function of x. Okay, we don't know what is x actually. Okay, but for, let's suppose if I would say it is the 2 and it is the 5. Okay, let's a equal to 2 and b equal to 5. So if I'm saying x belongs to, because these are the 2 points a and b, so it's mean x is technically belongs to the interval between 2 and 5. Okay, so it mean x could be 3, x could be 4, if I am mentioning that these are the discrete points. Discrete points are, for example, if I'm saying discrete point are those points which are represented in the form of integers. For example, 1, 2, 3, 4 and 5. Okay, that's it is not like 1.1, 1.2, that those are the continuous distribution. Okay, so if I'm saying x is belongs to a and b, which are 2 and 5, so it means x could be 3 and 4, pertaining the condition if x is if I'm mentioning that these are the discrete points. Okay, for example, x could be 3, x could be 4. Okay, so x could be 3, x could be 5. Okay, now where do we use these sort of these sort of things? Okay, especially in economics, when we do, for example, when I would say when we're doing any constraints optimization. Okay, so there we use these sort of phenomena where you can use in other domain as well, but I'm giving you the perspective from the economics. So there we use these sort of phenomena. So x belongs to a and b. For example, we here we have a graph, and these are the quantity and these are the price. Okay, so these are 2 points. For example, let's suppose do a graph. So it's mean we have some limitation, for example, this and this. So there we use this sort of phenomena. Okay, so there are multiple ways to write this thing, and both are and all are the same. For example, if I'm saying x belongs to a and b, I can also write if I'm saying x is between a and b, x could be a and b. Okay, let's suppose if I'm saying x is not a and b, x is between a and b, so I can say this. Okay, I can also write x in a and b. Okay, I can also write a and b. Okay, the subset of let's suppose if I'm saying in this case we were having the discrete number, so I can say that these are the integers, and it's a subset of integers. Okay, I'm saying, or if I would make it the continuous, like 1.1 and 1.2, so I can say it belongs to the real number as well. Okay, if we can also write x belongs to r. Okay, or integer. Okay, integer, and a less than or x is less than or equal to a, and sorry, greater than or equal to a and less than equal to p. Okay, or we can also write x belongs to a and b. Okay, if we have the integer. Okay, integer. Okay, or we can also write integer like this. Okay,